Optus, one of Australia's largest telecommunications companies, experienced a major security breach in September 2022 that affected approximately 9.8 million customers. This major incident questioned the Australian security of information standards and criticized how businesses implement and handle these security issues. Therefore, we would discuss questions about recovery methods for Optus using hypothesis testing and optimization. Using the Optus data breach as an example, we can test the following question here using hypothesis testing. In this problem, it says that Optus is installing new antivirus softwares. The antivirus software supposedly stops 100% of all viruses detected. However, an employee believes that this is not the case. Therefore, he tested the software by injecting 25 different viruses 8 times and recorded the results of the amount of viruses detected and blocked each time. The average amount of viruses stopped by the antivirus software is 22, with a standard deviation of 2.5. Therefore, using hypothesis testing, we can test whether the antivirus software is working effectively at a 95% confidence level. In the first steps of hypothesis testing, we need to state the null and alternative hypothesis. In this case, would be H null would equals to mu equals to 25, as he injected 25 different viruses to test the antivirus software. Therefore, the alternative hypothesis would equals to mu does not equals to 25. Since we're working with a 95% confidence level, we can know that the p-value is equals to 0.05. This will be later used to determine whether we reject or accept the null hypothesis. Now, continue on with the hypothesis testing, we should gather some information from the problem above. So here we know that the sample size is 8, so n would equals to 8, and our x bar, our mean, is equals to 22, and also our population standard deviation is equals to 2.5. Now we can continue on the hypothesis testing using a z-test. The formula for a z-test is equals to your x bar minus your null hypothesis over your population standard deviation divided by the square root of your sample size. In this case, we would be using our x bar 22 minus 25 over our population standard deviation, which is 2.5, divided by the square root of 8. This will give us a z-score of approximately negative 3.39. Now we use that z-score to compare with the p-value, and to decide whether we accept or reject the null hypothesis, we need to do our hypothesis testing on these decision variables. So if our z-score is less than 0.05, our p-value, then we reject the null hypothesis. If our z-score is not less than 0.05, then we accept the null hypothesis, or we do not reject the null hypothesis. And in our case, since our z-score was negative 3.39, this means that it is less than our p-value of 0.05. Therefore, we would reject the null hypothesis. So our conclusion would be to reject the null hypothesis of mu equals to 25 and state that the antivirus software is not working effectively. In the second part, we will be discussing linear programming and profit optimization. Continue on with the Optus issue. After the data breach, Optus developed two new mobile and internet services plans that offers enhanced security for their mobile and internet services. Simultaneously, they have also considered between 3 different companies to outsource in assisting them to develop these new services. We should identify the most suitable amount of plans 1 and 2 to be produced using a linear programming model. We should also identify what the optimal profit is devised from these new plans. In this table, it shows the amount of hours it takes to develop plans 1 and 2 by 3 different companies A, B, and C. At the bottom of the table, it also shows the profit contribution per unit offered by these plans. And on the right side of the table, it shows the labor hours available to develop these mobile and internet services plans. To continue on with the linear programming model, we need to first state the maximization function. And using the table here, we can state that the maximization function is 80 times P1. We'll use P1 as plan 1, and then plus 72 times P2 as plan 2, and that's our maximization function. Next, we need to identify the constraints for this linear programming model. So in this table, we'll be using the hours it takes to develop each plan and the hours available to develop each mobile plans as the constraints. So here are the constraints of this table. The constraints, and our first constraint for company A would be 0.45 times P1. That's how long it takes to develop plan 1 for company A, plus 1 times P2 is less than or equals to 40, because that's the labor hours available to develop these plans for company A. So for company B would be 1.2 times P1 plus 0.5 times P2 is less than or equals to 60. And lastly, company C would be 0.45 times P1 plus 0.35 times P2 is less than or equals to 35. Here is an Excel representation of the table that was listed in part 2. So as you can see, there is the companies A, B, and C with their production rate of plans 1 and plan 2 in hours. And then down here is our maximization function, 80 being the profit contribution of plan 1 and 72 being the profit contribution of plan 2. So firstly, we need to figure out the suitable amount of quantity plans produced of both plans in these cells here. So to do that, we would be using Excel solver. So first, we need to multiply our constraint. So to do that, we would use the formula of sum product by multiplying our company A constraints, these, by our quantity of plans that would be listed here. And since we want to do this for all 3 companies, we would want to lock these cells in place so we can just drag the formula down. To do that, we just do this, and there we go. Now each formula would multiply their constraints by the quantity of plans produced here. After sorting out the constraints, we need to finalize the maximization function so it could be used to find out our suitable amount of quantity plans to be produced. To do that, we would use the sum product formula again, and this time we will be multiplying our maximization variables by the suitable amounts of quantity to be produced of each plan in these 2 cells. And then now we have our formula completed. So now we can find out how many plans that we need to produce for each plan to make a profit for Optus. To do that, we would use Excel solver in here, and here is our conditions that we need to fill in. So the objective is our profit, so this cell here, F6, and the cells that we need to be changing is our quantity of plants to be produced. So these cells here, and then subject to constraints, we just add our constraints that we did here. So add our cell reference are these ones, and then since they're all less than or equal to, we just keep that symbol there, and our constraints would be the ones here, since these are the hours, the limited hours available for each company to produce these plans. Now we just click add, and okay. So now we have our constraints in here. We keep this as simplex LP and press solve. And there we go. This is the number of plans to be produced by each company and the profits of both plans for Optus. To summarize, the optimal production quantity for plan 1 would be approximately 41, and the optimal production quantity for plan 2 would be approximately 22. And together, the optimized profit developed by both plans would be approximately $4,832.82.